Hi, I'm Will Village. I've been a teacher for the last 15 years, teaching grade school, high school, and college. I've taught all levels of math from multiplication tables to college calculus to biology and to AP physics. I've also tutored hundreds of kids in the subject, and from local schools to prestigious schools like the Bronx Academy of Science and Stuyvesant in New York. And in my experience, I've identified the major deficiency that most review guides and teachers don't address. It's how do you answer these free response questions? So the purpose of my book, and an example of what I'm going to show you right now, is how do you do a blank derivation? How do you do graph problems? How do you do the conceptual problems? And how would you do the experiment problems? And right now I'm going to walk you through what a student's experience is to answer these questions step by step.
All right. Hi, Mira, and hi, everybody. I'm going to give you a brief overview of a 2019 AP Physics example problem. And this is taken directly from the College Board. And let's just go right to it. So, Mira, have you had an opportunity to look at this, by the way?
Yes, I did look over the problem.
All right. So this first one here is a great example of, I would say there's four types of questions on the AP exam. There are kind of conceptual understanding that come out in short answer. There's graphical, there's derivations, and there's design experiment. And this one kind of has a mixture of those. So in this first problem, you're presented with this situation. You have this block connected via a rope to another block on top of a table. Now, gravity is going to want to pull this block down. Force of gravity is going to want to pull this block down. But there's a tension in the rope, F of t, that is going to pull this mass to the right. Correct? This makes perfect sense to everybody, right? So one of the things I recommend whenever you approach an AP Physics problem is, number one, before you go about anything, picture the physical system in your head. Picture how it works. See these two blocks moving together. As this one goes down, this one goes to the right. Envision that system. This is physics after all, right? It is the science of describing physical reality with equations. So in this first situation, we're presented with a hypothetical, and they say, look, suppose the mass of block A is much greater than the mass of block B. Estimate the magnitude of the acceleration of the blocks after release. So it's one of the things I recommend is exaggerate it greatly in your head. Because I think if you exaggerate it just a little bit, you might be like, I don't know, maybe I kind of get it. So if I make the block a little bit bigger, kind of helpful. But let's blow this block up and make it huge. And by this ridiculous exaggeration, what this helps you do is to be like, oh, look, this little mass is not going to do much of anything to accelerate this mass, right? It makes it very obvious. It's such a simple little trick you could do in your head. So this block is going to pull it down. This heavy mass is going to resist the whole thing. You see what I mean about picturing it well, right? It's pretty cool. It's pretty cool. So there's all these little tricks, right, that you can do to make your life easier. So estimate the magnitude of acceleration of the blocks after release. Now, by the way, they say briefly explain the reasoning without deriving or using equations, which, of course, this is a qualitative answer, right? So you got to get used to answering that. And so when you do answer it, these are the points from the official answer guide. And it comes out like this. First of all, the acceleration is going to be much smaller, right? This should make sense to everybody. The acceleration will be much smaller because you have a much bigger mass to move, correct? But the second point is you need to make sure that in your answer you provide a justification that uses Newton's second law or something like inertia. Right? These are how the test graders will award your points. You have to play the partial credit game because that's what you're up to, right? You're trying to get a 5, hopefully. So And that's about it. So make sure in your answer that whether you see this in my book or you see this in the official College Board solution manuals, always look up the partial credit so you could learn how they award points. And one of the things you're going to find, unfortunately, is that they're kind of inconsistent. In fact, they're very inconsistent how they award points. So my recommendation in general, over answer. All right, so next part. Now, suppose the block of mass A is much less than the mass of block B. So let's simulate that over here, right? We made a mass very large. Let's make this mass very tiny. Tiny little guy. Okay, it's floating off of the plane right now, but we get the idea, right? So look, this mass, if it's so tiny, it's negligible, right? This mass here is just going to fall towards the ground, basically as if this other mass wasn't even there. It'll accelerate much faster. It's almost like cutting the rope, right? It's just going to go in free fall, basically. Tiny little mass resisting it. So, again, understand the physical situation first and write your answer based from that understanding. And I do understand the tendency that a lot of students have is like, it's almost like they feel like, I don't have enough time to understand it, right? I don't have enough time to understand what's going on. There's time going by. I only got 25 minutes for this problem. I got 5 more to go through. But you have to. And you'll find that if you calm yourself down and you breathe and you move from that understanding, you'll get through it faster. I guarantee it. So step one, panic. Step 2, understand the problem. All right. Next one. So here's what I'm talking about, that inconsistency, right? Look for part 2. That it's one point that just for stating that the acceleration will be much greater or near the rate of gravity, but there's no points awarded for justification. There's already an inconsistency between the first and the second part of the same problem. Right. Your face, Mira, reflects what I see in everybody. They're like, that's not fair, and I agree. So this is part of the wonkiness you must understand about the AP exam. I think it's a very well constructed exam, and I do think it does a good job of capturing what college physics is actually like, at least non-calculus based. But you have to get used to how they grade it, just like you'll have to get used to partial credit in college too. All right, now let's go back. Now we have this free body diagram thing, and Mira, curious if you personally are familiar with doing free body diagrams. Have you done those in your physics class?
Yeah, we've done a few.
Okay, good. So
not really complicated, but yeah, basic.
Okay,
ones.
Basic free body diagrams, quite useful in a whole study of engineering called statics. How do forces interact with one another and dictate what happens to a physical system? So now basically they're saying, let's just look at this original scenario here and draw the forces acting on each block. So block B, you have gravity pulling it down, which I will just denote by F of G. You have the tension in the rope pulling it back up. Now, this one in particular doesn't require that you draw the arrows to scale, but some answers do require that you draw the arrows to scale. So I'm doing it just out of good habit. So F of G must be bigger than FT. Why? Well, because the system is going to accelerate downward, right? There's a force imbalance. FG must be bigger than FT. Otherwise, if they were equal, it would stay in equilibrium. All right, so no problem there. Now, block A, you have the tension pulling to the right, the same tension coming from the rope, and you got its mass. I'll call this F of GA, and I'll call this F of GB, by the way, and a normal force acting up, FNA. But I'll make that a little bit more clear down here. You have tension to the right, its mass, F of GA, acting down, and an equal and opposite normal force acting up. That's about it. Again, they're not picky about the I just made f of GA approximately equal to f of n. My two FTs look about the same length. Of course, one of the things I omitted is that this is assuming that block B's mass is greater than block A's. We don't know, but I'm just playing with this. So, and this is f of GB. Now again, look at how they shop for partial credit, right? Drawing and labeling the normal force. So there is points given for the normal force. 1 point for correctly labeling gravity on both of them. And then tension force on both dots. So far, so good? Yeah, making a sense? All right.
So if you were to only put the gravitational force or the tension force on one of the dots, you wouldn't get that point at all?
Yeah, right. It's very picky. It's very picky. And so, again, I will state this again to anybody out there: learn the partial credit, learn how they grade, adjust your answers around that. And I understand a lot of teachers and even prep books don't do that, unfortunately. They don't do partial credit coaching. Learn it and play that game. And this is totally analogous to what you have to do in college too, right? You have to learn the tendencies of your teacher, right? When you have free response, open exams, what does my teacher look for? How particular are they? You always have to learn to play the game. All right, next one, moving on. Now, here's my favorite part of this. This is the bane of existence for most people in AP Physics. It's derivations. I particularly love them. I think they're beautiful. They provide a profound way to learn something new about physical reality. And it is really the heart of physics. So they're going to ask you to do derivations. And I find that this is where kids are the least prepared, because they will do their Giancoli textbook and they will plug through problems with wild abandon. They'll do those level 3 problems that are quite difficult. But a lot of times they're used to doing a problem that is based in numbers. They're not used to doing the same algebra with purely letters, and they get scared. They're like, it's the same algebra, so you have to practice solving with symbols. So here we are to derive an equation to describe the acceleration of this system. So I'll reiterate, here's what our arrows look like. You got gravity downward. You got tension upward. And I'm going to ignore putting the other arrows for this mass here because it's not relevant to our derivation. So this is called Atwood's machine, or two masses connected across a pulley. It's almost certainly going to show up on your exam. It's one of the favorite topics they bring up because and there's so many ways they can trick you on it. So if you don't get the actual derivation, you're not going to have a good time. So understand the derivation. And so here's some simple things you should follow. Make a separate equation for each system. So let's talk about block 1. So for block 1, now remember, you always, when you're doing Atwood's machine, you're doing this in terms of forces. You're using Newton's second law. F net equals ma, right? The net force on the system. And by the way, we could describe, it's a vector quantity. You must describe things independent in the y and the x plane. Well, in the x plane, all you have is the tension, and that's equal to mass 1. I'm going to give it the correct label. Make sure you do that. Times the acceleration. And similarly, for block 2, we make an equation. F net, the net force acting on the system, is equal to ma. One little important point that I think is often overlooked, that I've seen a lot of teachers omit when I've tutored many students through the years, is that make sure the directions for your two systems agree. I have implicitly stated that rightward is positive for this system. Thus, downward must be positive for this system. Otherwise, you have a disagreement in the relativity between the two systems. This cannot happen. So, thus, anything acting downward is given a positive. So, we got f of g acting down. What's acting against us? F of t. And that's equal to m2a. Now, just some conceptual things to understand really quickly. These tensions are the same. this ft is the same as this ft. They are equal. Thus, you could set them equal on this basis. These are two equal ft's. And similarly, by the way, the accelerations are equal, right? The rate at which this mass is falling is the rate at which this mass is moving to the right. Must be, right? Otherwise, it just doesn't physically make sense. They will move together. So, because of that, I can plug this thing, M1A, into there. And so we get f of g minus M1A equals M2A. And by the way, we just make a simple substitution here. F of g is mass times gravity. But remember, we're talking about block 2 here. So we're talking about the mass 2 times gravity, right? Because for block 2. And then minus M1A equals M2A. Now our task is to solve for the acceleration. So any derivation, your goal is to get the variable of interest by itself, and then everything else on the other side. A on one side, everything else on the other. So let's start to group A on one side. This is relatively simple algebra, and I see this with students all the time that they might not know how to do this bit of algebra when they've certainly done harder math, right? They've done pre-cal, oftentimes they've done calculus, and for whatever reason, right, it's like your brain memorizes things in certain contexts, right? It's like, oh yeah, I'm doing algebra in algebra class. I didn't realize I had to do it in physics. Do you know what I mean? Like, this happens all the time. You'd be surprised. So I factor out A. Just a silly little thing. I pull an A out of both because it's a common term. And then now we get this thing by itself. M2G over the quantity M2 plus M1. And that's A, our acceleration. Makes sense? Nice and clean, right? All right, so let's look at how they award points for this. 1.4, just showing that you could generate equations. Just approaching, using Newton's second law, attempting it, get you a point for doing it for both systems. So again, if you're completely lost and you have no idea how to do a particular problem, which might happen, for the love of God, just jot down anything. You might be surprised that you might get partial credit for it, and thus, you go up a whole point on your exam for it. You can milk it like this. I know in years past that all you had to do was get a 60% or greater on the exam to get a 5. Think about that. You only had to get 60% of the problems right to get a 5. And so one of the things, the AP exam is, they're almost expecting that you're not going to get them all right. So there's like an anxiety that comes with it, and the student will second guess themselves. It's okay, you're not going to get everything. Almost expect that. Move on anyway, and you might still even get a 5. Even if you leave a whole problem blank, you might get a 5. All right, so generate equations using Newton's second law. Now, correctly substituting one equation into the other. Notice with proper labels. You must keep track of what is M2, what is M1. And lastly, this bit is incorrect, but this should be arriving at the correct answer. Last point there. All right? Next set. Now, this is rather interesting. This happens a lot on the AP exam as well, and I get where people get tripped up. So if you look at this, it says, basically, consider the scenario that you already did. That this mass, again, is much less than block B. Does your equation for the acceleration of the blocks from part C, so does this equation here agree with what you said previously? Yes or no? And then explain your reasoning. So one of the things I recommend is plug in sample values, if this makes your life easier. And you can illustrate this for the test graders. So let's say that mass 2, so this again is 2, this again is 1. So that's mass 2, mass 1. Let's say, and always make simple sample numbers, make your life easier, right? So say this is 100, and say this weighs 1 kilogram, right? This weighs 100 kilograms, this weighs 1 kilogram. And plug those in. So look, that's 100 times gravity, I'm just going to call that 10, over 100 plus 1, right? So this is about 1,010 over 101, and that's about an acceleration of approximately 10. So here I've proven it, right? I've done a brief mathematical substitution. This would suffice if you showed it like this, and then maybe you'd make a comment like, using sample numbers, we arrived at approximately the speed of gravity, which agrees with my previous answer. Right? State it, be very direct with your test graders. Tell them this is what's going on. Never try to fill in every possible blank, because they're trying to see, do you get it? Can you articulate your understanding? So, again, rather unfortunate, look at this. 1 point only for all that work. Very inconsistent, and I find that frustrating. I would understand why you would too. And I have looked at the partial credit for literally every single exam that the AP, that the College Board has given since 1999. And I am telling you, they are massively inconsistent in how they grade. So understand it, get used to it, over answer. All right, last section. This one I like. This is my favorite part of this, other than the derivation. It says, look, while the blocks are accelerating, the tension in the vertical portion, so they're saying the initial tension is, we'll call it T1. So we have this initial system here, as it was originally. That initial tension, let's just call that T1. Now, they're saying something new is going on, and I'll illustrate it down here. Now we attach a pulley which has mass. What would happen to the tension, right? So would the tension go up? Would it stay the same? So again, this is where I say there's a great benefit in exaggerating it in your head, right? This mass is not negligible. So if this pulley were very large, you'd be like, okay, I got to rotate this pulley, right? If the pulley was extremely large, you have this giant mass that has inertia that you need to get rotating, right? It'd be like if you have a giant Flintstone-sized wheel in front of you and you're trying to get that thing moving, right? It'd be hard to get that thing to budge versus a small wheel, right? So if you think about it like that, make it more practical, it's like, oh, well, it's going to be harder for the mass to fall, right? So again, this is about, in your mind's eye, create a practical understanding of the thing. Exaggerate the heck out of it, and it makes your life a world easier. If you just exaggerate it a little bit, even in my diagram here, might not be clear, but a giant circle here, you know, getting this thing rotating, if this was mounted here, be harder to get it to rotate. So thus the tension goes up. So again, this one is 2 points. So 1 for selecting the correct answer, that the tension would go up. So 1 point here. And then saying, so maybe I'll provide like a sample justification. It would be something like, because the mass has rotational inertia now, and that requires a force in order to accelerate it rotationally. Thus the net tension would go up, right? And so any answer you give on the AP exam needs to be like almost a dry, because of this, therefore this. And thanks to Newton's second law, this would happen, etc., right? Be like, because of this, therefore that. Very much so an if-then style of speaking. Get used to it. Don't worry about your grammar, by the way. They don't grade on that. They just care, does it make sense? This is not an English exam. So don't even worry about your punctuation if that's tripping you up. Don't worry about your commas. Don't worry about a semicolon. Just answer succinctly, dryly, logically. That's the style of answer they're looking for. And I do get that people would have the tendency to answer it as if they're doing an English essay. But that is not what they're looking for. And don't also be afraid to, in your answers, speak with equations. You could say something like, because F equals ma, etc. Speak with equations. Physicists do it all the time. All right.
Thanks again for watching. I hope the video was helpful. Make sure to like, subscribe, and turn on notifications. I'm going to be releasing one video a week up until the upcoming exam. You could find a link to my book in the description below. It's available in both Kindle and printed format. It's actually a color book. And leave a comment below asking me anything you want in regards to AP Physics. I could do an entire solution to any question that you have. All right, well, that's it, and good luck.